Now, hello everyone. Today we are going to start a new topic, that is Prism. So we shall start now. Now that is Prism. Prism can be defined as when two rectangular transparent surfaces, say A, D, E, F, E, prism can be found when two rectangular transparent glass surfaces inclined at a certain angle. Now in this figure, A, D, F, C, A representing the transparent rectangular glass surface. B, E, F, C, B in this figure, B, E, F, C, and again B representing the base. Now if any section of this prism is cut by a plane perpendicular to its edges, they will form a principal section. And this is the ABC is the principal, ABC is the principal section. Hello student, today we are going to study the deviation produced by the prism. Now we have a figure of a prism, that is ABC. ABC will representing the prism. Now this is an incident ray which is incident on the surface AB. Outside of this prism is a rarer medium and its prism itself a denser medium. So this incident ray incident on this surface AB and enter into a denser medium. All of you know that when a ray is incident ray in a rarer medium enters into a denser medium, it will bend towards the normal. So this incident ray in rarer medium moves in a denser medium, so it will bend towards the normal. I is the angle of incident mixed with the normal, this is the normal, and R is the angle of refraction made by this ray with the normal. Again, further this ray move an incident on the surface AC, glass surface AC, and act like a incident ray. And this angle R dash become angle of incidence, and it will make this ray will make this angle with the normal. Further, this ray further move towards the rarer medium. So, as per the rule, this ray move away from the normal, and the angle made by this ray with the normal is given by I dash. This incident ray moves further and meet with the emergent ray here at M. This both ray will make an angle with each other, and that angle is called angle of deviation. Now further, in quadrilateral AQN R, angle A plus angle QNR are opposite angle and their sum is 180 degrees. So we write it as A plus angle QNR equals to 180 degrees. Now in triangle QNR, if you see that QNR, the sum of angle is 180 degrees, so R plus R dash R plus R dash plus Q and R equals to 180 degree. Now in this equation we put the value of Q and R from this equation number 1, that is 180 minus A. Further, that is R plus R dash plus 180 degree minus A equals to 180 degree. R plus R dash minus A equals to 0. So R plus R dash equals to A. We get a new relation between A and R dash, that is represented by equation 3. Now in triangle MQR, as you know that this is the angle of incidence which incident ray makes with the normal. So this angle M Qn is equals to the angle of incident. So we can write the angle this MQR equals to I minus R. Further, you see that this is an emergent angle and this angle is equals to the MRN. So this angle MRQ equals to I dash minus R dash. We have these two angles MQR and MRQ. This angle delta is the exterior angle and this external angle basically makes is the sum of the two internal angles, that is MQR and MRQ. So we have put the value of delta equals to MQR here plus MRQ equals to delta. Now put the value of MQR, that is I minus R, and MRQ, that is I dash minus R dash, equals to delta. Now further, if you see that I plus I dash equals to delta plus R dash. In this equation, R plus R dash can be replaced by A. So we put A plus delta equals to I plus I dash. Now we have the relation between this, the sum of angle of deviation and angle of prism is equals to the sum of angle of incidence and angle of emergent made by the rays from the normal. Thank you. Now student, we are going to discuss about the variation of angle of deviation with the angle of incidence. For that we will have to plot a graph between angle of deviation with angle of this angle of incidence. Now in this graph you see that we take angle of deviation along this axis and angle of incidence along this axis. We find that if the angle of incidence increases, the angle of deviation decreases according to this relation. Now, at I equals to I dash, the angle of deviation becomes minimum. That means del equals to becomes equal to del suffix m, that is del m. Now further, after this I equals to I dash, when angle of incidence increases, it will further increases. The angle of deviation is further increases. If you see that in this graph, that angle of incidence is further increases after I equals to I dash, the angle of deviation also increases just because of this relation again. When I equals to I dash, that means del equals to 2I minus A. Now hello everyone, today we are going to discuss the relation between refractive index and angle of minimum deviation. Now we have a prism here, A, B, C will represent the prism and it has an angle. The angle of this prism is given as capital A. Now this ray is the incident ray which is incident on the surface AB and makes an angle I with the normal. Further it enters into a denser medium and it bends towards the normal and make an angle R, which is angle of refraction. Now this ray move further and incident on the surface AC and move outside, that is into a rare medium, and move away from the normal. This ray incident on this surface AC makes an angle R dash with the normal, which is the angle of incidence of the ray with the normal. Now we have a condition here, if I equals to this, I equals to now if this I equals to I dash, in that case R is equals to the R dash. So we have the condition here, when I equals to I dash, this R equals to R dash. In that condition, the angle of deviation becomes an angle of minimum deviation. It is given by this. Now, in previous slide, we already proved that A plus delta equals to I plus I dash. We already proved that A plus delta equals to I plus I dash. As per the condition, when I equals to I dash and R equals to R dash, delta becomes the angle of minimum deviation. So we'll replace this delta with delta minimum, and we get here A plus delta minimum equals to 2I, and ultimately we get I equals to A plus delta M by 2. Now we have another relation, A equals to R plus R dash. We put R dash equals to R, we get 2R. R equals to A by 2. We have these two values, I equals to A plus delta M by 2, this one, and R equals to A by 2. Now we use Snell law to find refractive index, that is mu equals to sine I upon sine R. We put the value of these I and R in this equation, or you can say that in Snell law. So then the value of this mu becomes sine A plus delta M by 2 upon sine A by 2. Thank you.